Hi everyone, welcome back to JDCodebase. Today we are continuing with our stack problem part 2, and we will solve two very interesting problems: evaluate postfix expression and next greater element. Both of these are very common interview question, and they are perfect to understand how stack logic actually works behind the scene. So before we start, let's quickly revise what a stack is. So whatever a stack follows the LIFO principle, that means last in, first out. And so whatever goes in last comes out first, just like a pyroplate or browser tabs in history. The main operations are push, pop, peek, and stacks are used in many real life cases like undo, redo, browser history, expression evaluation, which is what we will learn next. So first problem is the evaluate postfix expression. Now what exactly is postfix? It is also called reverse Polish notation, where the operator come after the operands. For example, in infix, we have 2 plus 3 multiply 4, just normal expression. And in the postfix, we have first operand, then operator. The best thing about postfix is you do not need brackets or parentheses because the order of evaluation is already clear from the position of operator. So let's see how we can actually evaluate using a stack. So first create an empty stack and traverse the expression from left to right. If you see an operand just like number 2, 3, 4, 5, push it into the stack. Push it into the stack. If you see your operator plus, minus, multiply, divide, pop the top two elements from the stack, apply the operation, result is equal to operand 1 and operand 2, and push the result back to the stack. After the loop end, whatever is left on the top of the stack is your final answer. So let's understand this example. 2, 3 multiply plus 9 minus. So first is the 2, a operand, we push into the stack. Then 3, again operand, we push into the stack. Again operand 1, push into the stack. Our stack becomes 2, 3 and 1. Now multiply a operator, so we extract last two element, which is 3 and minus 1, and multiply it, 3 multiply 1, and after that result is pushed into the stack, so our stack becomes 2 and 3 only. Again operator, we extract last two element, 2 plus 3 5, and push into the stack. Again operand 9, push into the stack, becomes 5 and 9. Again minus a operator, last two element extract, 5 minus 9 is equal to minus 4, and push minus 4 into the stack. So our answer become minus 4 as the one element is left in the stack. So let's move to VS Code and write the code step by step. So first create a function called evaluate postfix. Function evaluate postfix. It takes an expression and make a stack. Let stack is equal to empty array, empty stack, and for let character of expression, and we have to split this expression by space. And if is not a number, then we have to just stack dot push this character. So basically if it is a number, we have to push into the stack and convert into the number format. Else if it is a operator, means plus minus something like that, then let b is equal to stack dot pop let a equal to stack dot pop, extract the last two elements from the stack and apply a switch, a character, and a case is the plus stack dot push a plus b and break. So if we have to write the cases for plus, minus, multiply, divide. just change the operator, minus, multiply and divide. Here also multiply and divide. So after that, in last we have to just return stack dot pop last element from the stack, and let's make this console.log evaluate postfix, and expression is our 2 3 1 and multiply plus 9 minus. So let's run this node 0 1. As you see, I will get an answer -4, which is correct for this. So basically, first I create a simple stack, empty stack. Then I'm splitting the expression by spaces, and then I'm checking each symbol one by one. If it is a number, we push into the stack. This easy NaN is the method from in the JavaScript inbuilt. So if it is an operator, we pop two elements, let B and let A, and apply that operation according to this by using the switch case, plus, minus, multiply and divide. And finally everything is done. This stack will have only one value, and that is our answer. So in last, stack.pop and return this. And so let's when I run this, I get -4 here. So let's move to next problem. So next problem is the next greater element, or NGE for short. So this one is the slightly tricky, so we will take it step by step. So the problem says for each element in an array, find the next greater element that appears to its right. If no such greater element exists, we will return -1. So like 4 minus 4 5 2 25. If I see 4, next greater element of the 4 is the 5 here, and if I see at the position of 5, next greater element C is the 25. If I add the 2, next greater element is again 25, and the 25 next greater element is nothing, so I have to give the -1. So 5 25 25 and -1. So let's use the optimal stack approach here, is the B of n time. So how it works, just create an empty stack first, then traverse the array from right to left. Every time we move to left right, but this time we have to move to right to left, because every element we need to look on its right side. For each element, pop smaller element from the stack. They cannot be the next greater. If the stack still has something left, it is the top of our next greater element. If the stack becomes empty, then it means there is no greater element, put -1 here. And finally push the current element to the stack. The reason we go from the right to left is that the stack will always hold some elements that are to the right of the current one. So let's try run the same example, 4 5 2 25. So what happening is, we always first we see right to left, see 25. So there is no element greater in the next, so we push -1, and this next greater element is -1, and push the 25 here. So after that we see the 2, so there is again no greater, so the greater element is the 25 here, so next greater element is 25. So after that 5, so again we see 2 is smaller than 5, and we pop out this 2, and next one is the 25, and see the next greater element is 25 for this 5. So for the 4, the next greater element is the 5 here, because 4 is smaller than 5. So what happening here is, we always keep only useful element in the stack, means there is no need to enter all the elements, just put which is the next greater element. So whenever we find a smaller number like 2 here, we just remove it, because it cannot help anyone on the left. So that's how we make it efficient. Each element goes into and out of the stack only once. So let's move to VS Code. So let's create a function called next greater element function next element, and it takes a array. So const stack is equal to blank array, and const result equal to new array dot arr dot length dot fill -1. So we will go from the right to left. For that we have to let I equal to arr dot length -1, and I is greater than equal to 0, and I minus minus every time. So first we have to check remove the smaller elements, while stack dot length means every time we have to see whether the stack has some elements or not first, while stack dot length, and stack of stack dot length -1 is smaller than equal to arr of I. Then stack dot pop, then if stack dot length means it is greater than the value of this arr of I, then we check if the stack dot length, then result of I equal to stack dot length -1. Then push stack dot this arr of I. So in last we have to return this result. So let's run this console.log next greater element, and it takes value 4, 5 to 25. And if I run this node 0 2, I will get 5, 25, 25 and -1. So here I am creating a stack and a result array filled with the -1. So then we start from the end of the array by using this let I equals to arr dot length -1. And I will for each element I remove all elements from the back that are smaller or equal to the to it. Why? Because they cannot be next greater for any future element, like we remove this 2 from here. So for this situation we have to write this while loop, and then if there is still something left in the stack, that means the top element is the next greater element, and in the end we push the current element to the stack because it might be useful for the next element on the left. Like every time we push 25 here 2 and 5, every time we push this arr of 5, and after running the code we get the 5, 25, 25 and -1 because we return this result array. So let's summarize this. This problem is the evaluate postfix. It is an expression evaluation and just key operation of push and pop. It is again big of n time, which is also great. So next greater element array comparison we will learn, and this stack runs from right to left means top to bottom means array runs from right to left, and this big of n. So both problems are used the stack in different ways, but the main idea is pushing and popping elements smartly to reduce the time complexity. And alright guys, that is for the today's video. We learn how to evaluate postfix expression, how to find the next greater element using stack, and you will get this PPT in the video description. If you find this helpful, don't forget to like, share, subscribe to JDCodebase.